Today we're going to own facts and logic, epic style with facts and logic. We're going to unverify verification. We're going to falsify falsification. And we're going to scientifically prove that science isn't exactly what it pretends to be. This has been the new season of Not Related. First episode of the new season. Go to notrelated.xyz. All right, what are we talking about today? I want to talk about two main things. I'm going to say that this is mostly on one particular book, but to get there, we got to do a little journey, a journey that will be edifying. I'll tell you that. The book I want to talk about is Against Method. It's a book by a guy called Paul Feyerabend. It's about what is usually called Epistemological Anarchism. So I want to talk about that book and the greater point of what's called sometimes the demarcation problem, the problem of demarcation. It's a term you'll hear in philosophy of science. Now, I've done a lot in philosophy of science, and I will go ahead and say that I don't believe in the whole field. And this is an explanation as to why. In fact, Feyerabend effectively does not believe in the whole field. But what is the field of philosophy of science? What actually is it about? Well, we have to go back around to the beginning of the 20th century. Now, of course, people have been thinking about science since forever. But the 20th century brought a somewhat unique view, the unique view of science that we have nowadays. Okay. Now, in the earlier 20th century, there was a movement that's usually called logical positivism. And although it doesn't really exist anymore, basically everyone nowadays is some kind of logical positivist clone or derivative or something, even though a lot of people say they hate it. Now, if you listen to me on live streams, whenever this comes up, I will complain to no end about the horrors of logical positivism and how it's basically destroyed everything. But let's talk about it. We don't need to talk about it in specifics, but just the general ideas and why is it relevant. Well, logical positivism brought to bear the so-called demarcation problem. And the demarcation problem is an attempt to figure out what is supposed to be the difference, the thing that separates science, quote unquote, from everything else. Specifically, during this period, there arose the idea that there are two different kinds of really, when someone tries to study science, there are two different kinds, right? There's science, real science, and then there's pseudoscience. There are some people who do things wrong. Maybe they have bad methods. Maybe they believe the wrong things. Maybe they have wrong assumptions or something like that. But in some way, they're doing things wrong. And logical positivists were part of a greater movement to, and this was something that sort of came out of the fact that science, especially in the 20th century, became something that a lot of governments started funding. You sort of had court scientists, I mean, not in the sense of a king's court, but, universities that received a lot of government fundings, a lot of colleges did this, and it sort of became an industry to say, I'm an academic, I need some kind of funding, so I need this lifetime tenure, and I need to get paid. But one thing that emerges very quickly from that is, wait, I don't want you to fund these other guys. I'm doing real science and they're not. Okay, so there has to emerge some kind of distinguishing point as to, what is real science versus what is non-real science. Okay, now that is not necessarily a question that existed in the past. And that's not to say that in the past people just believed everything was equal or something like that. But people more or less had the views. If you look at scholastics or something like that, they would treat topics that we would sometimes consider scientific. Sometimes they'd be religious or theological questions. Sometimes they'd be occult questions, or people would talk about divination or things like that. There wasn't necessarily a boundary between what we now think of as being, there's science, which is its own rigid category, and everything else. Okay, so that's one thing that happened, and once science became something that had to be funded by governments, or at least was funded by governments, that's something you have to distinguish. Now, logical positivists went a little further. In addition to trying to distinguish science from so-called pseudoscience, they also had a very particular materialistic approach to the universe. That's to say that they especially did not like religion or ethics or so-called metaphysics, the more general category of all this stuff. That is, science is supposed to be, really science is hard science, and if you're doing so-called soft science, the word we have for it now, like, studying human societies, you have to do it, you either do it in a way that's reminiscent of hard sciences, or you basically can't do it at all. It's nothing like science whatsoever. Now, one of the books that is probably most popular during this period, it's sort of a late comer, but I think it perfectly illustrates this mindset, is a book by Ludwig Wittgenstein. Now, Wittgenstein, he actually went out in the woods into this cabin and he wrote this long treatise. He sort of did the Uncle Ted thing or the Thoreau thing where he went out and wrote something. Now, of course, I disavow this. I think what he wrote was terrible, but it's usually called the Tractatus, it comes from the Latin. It's known by a Latin term. It's known by Tractatus Logico-Philosophicus. And that basically means logical philosophical treatise or something like that. It's actually written in German. Now, it's interesting. It actually illustrates logical positivism, their mindset, very clearly, because it's not written like an essay. It's not written like someone who is talking to you or explaining a topic. It's actually written like an enormous logical derivation. Every sentence has a number, or really it's like ordered by a kind of system where these sentences prove the sentence that follows and stuff like that. It's all supposed to be a giant deductive system. And famously, it ends with this line that perfectly encapsulates a lot of the positivist viewpoint. I think in German, it's a somewhat famous line. It goes, in German, it's, wo wenn man nicht sprechen kann, darüber muss man schweigen. Which means, in English, something like, what you can't speak about things that you can't speak about, you have to go over in silence. You have to not talk about. Okay, that's the way I'll translate it, since I'm on the spot. Basically, it encapsulates this logical positivist view that there are some domains like religion or ethics or even a lot of social sciences or, all these kind of things which we cannot use, our logical positivist methods, our deductive methods to study. And on those subjects, we really can't say anything. We don't know anything about those. So you should probably just be quiet about them. And that sort of illustrates logical positivism. In case it isn't clear, it's often associated with the term Scientism, specifically because they had this viewpoint that everything should be using scientific methods. Now, of course, the important thing to note is that their view of scientific methods is not something universal. In fact, although we think of, we have this sort of view that there is this standard scientific method that is universal and used in all times and places if you're good at what you do, it actually isn't that clear. Now, as I said, this podcast, I'm actually getting you ready for Feyerabend. That is, Feyerabend's view is ultimately that this entire problem of demarcation doesn't matter. It's not something. There is no difference between science and pseudoscience. Now, how does this idea, the idea of the demarcation problem, evolve? Well, one of the first people who's sometimes classified as a positivist, I don't think he identified as a positivist, but a guy named Karl Popper. You've probably heard of this guy. He took issue with a lot of the things that earlier positivists said. Their idea was that, okay, we're going to make claims about the universe. We're going to state facts, okay, or make claims, and then we're going to try and verify them with scientific methods. It's their view is that that is what science is. You make claims, then you run experiments, you look at the universe and see if they are verified. Now, Popper, I don't need to talk about Popper for too long. You may have heard of him, but he popularized the idea that you shouldn't really try and verify ideas. You should try and falsify them if they're scientific. In fact, Popper says, okay, here's the difference. Here is the big difference between science and pseudoscience. Pseudoscience can never be falsified. And that sounds like a good thing. Well, if you can't be falsified, that's good. But Popper's point is, pseudoscience is, now in his personal life, he actually was a former Marxist, for example. And he used Marxism as an example of a philosophical viewpoint, a political viewpoint that is non-scientific, that's pseudo-scientific. Even though, of course, Marx's socialism is called scientific, quote-unquote, socialism to distinguish it from, the utopian socialists that were sort of before him. But Popper says, Marxism is not scientific for this reason. There's a Marxist can look at the world, and no matter what happens, his worldview will never be contradicted. And what he means by that is really Marxism is just a kind of language for talking about the world, but it's not like, let's say something happens, let's say there's a workers' revolt. Well, that's proof of, this specific statement of scientific socialism. Let's say a workers' revolt doesn't happen in this highly industrialized nation. Oh, well, that's just because of these reasons and my ideology. That is, there's always a way of dealing with exceptions. And, Popper says, okay, well, this is the reason Marxism specifically is not scientific. He made the same argument about Adler's psychology, or, well, really, no one remembers that nowadays, but he also made it a Freudian psychoanalysis, right? Because Freudian psychoanalysis is just a bunch of gobbledygook, okay? If you're a Freudian, you might say, okay, you might look at some guy, this guy married a girl who reminds him of his mother, okay? Oh, well, that's proof that he has some kind of Oedipal complex and all this stuff is going on in his brain. But what if he marries a woman that's the opposite of his mother, or different than it, or it just isn't really like his mother? Oh, well, that's because he's suppressing his Oedipal complex and he was attracted to her for this reason, yada, yada, yada. So Popper's point is that science makes claims, logical positivist state. It makes claims, but it also makes claims that could theoretically be falsified. That's not to say they will be falsified. If they're perfectly true, they might never be falsified. But in principle, they could run across some data that disproves them. Okay, so Popper's view, I think, is the standard view. Now, the philosophy of science is actually going to change a lot since Popper, but I'll say that what Popper believes is sort of the standard view that you are taught in popular culture, in school, right? If you watch Carl Sagan's Cosmos, or if you watch, Neil deGrasse Tyson's Cosmos, or whatever, they are basically going to give you a Popperian view of knowledge. That is, okay, science is about making claims about the universe. Oh, and it's deeply humbling because we're trying to falsify our views. That's what scientific experimentation is, okay? And I think the pop science understanding about how a philosophy of science works sort of stops with Popper, maybe with a couple exceptions. But Popper, of course, is definitely not, has a highly imperfect view of philosophy of science. Now, first off, falsificationism, it's not falsifiable, but that's a minor detail. There are a couple problems with falsificationism, or this general idea that Popper put out. Now, of course, if you want to take his view on it, I will say that the typical book you read is Conjectures and Refutations. That's by Karl Popper. I forget when exactly it was published. It'll be in the comments or the video description. Or the podcast description or whatever, but Conjectures and Refutations. And that's the idea that science is an issue of making conjectures and then refuting them and trying to refute them and going on. Okay, so what are the problems with this? Okay, now first, one thing that is noticed very quickly, if you look at the actual history of science, is that if you really follow Popper's view of falsification, literally everything has been falsified. Like, there is no scientific theory that actually has never, that isn't falsified literally every single day. In fact, it's a normal thing for scientists to say, okay, well, this data contradicts our theory. I'm just going to ignore it. I'm going to make up an explanation for why it's like that way, or something else. I'm just going to, that's nothing. Maybe I'll discover why that is, but I'm not going to throw out the theory. And in fact, this isn't really even a bad habit, because if you have a theory that solves for a whole lot of information, and then you have one minor exception, you're not going to throw out the baby with the bathwater. But Popper's idea of falsification is obviously not how science moves around, right? In fact, if you really think about it, it'd be sort of hard. I mean, that'd be a very hard metric to go by, because you're limited to making very, very restricted statements about the world that could have no exceptions. And you couldn't describe anything unless you perfectly understand how everything works, and including, you even have the ability to account for any possible exceptions. So there have been many who have noticed stuff like this. For example, I'll put an article from Chalmers 1999. He notes a couple situations where, for example, Newton, when he put out his theory of gravity, very quickly, within a couple years, there was good data from the moon that actually contradicted his theory of gravity. Or kinetic theory is another example he gives. But the big one that Feyerabend is going to talk about, again, I'm sort of getting ready, I'm giving you the historical background to Feyerabend, but the big one that he talks about is Galileo. Right? Now, in the popular press, I guess, again, in the Neil deGrasse Tyson view of the world, Well, okay, we'll talk about that later. I'll talk about it when I get to it. But we'll just say Galileo is a very good example. The geocentrism is a very good example of, one of these theories that theoretically was falsified, but there was good reason to continue with it. Either way, Popper also has some other problems. Like there are some statements, there are some conjectures that by nature can never be refuted. And I'm not talking about really weird, I'm not talking about like Gödel statements or something weird like that. I'm talking about existentials, right? So for example, if I say something like the earth exists, okay, how can you disprove that theoretically? I mean, an existential statement, if I say something like, let's take the example of Bertrand Russell that he gives of, there's a tea kettle in the middle of space or something like that, okay? If someone says, okay, there's a tea kettle in the middle of space, and you go out looking for it, there's never a point where you've just searched literally everything. There's always a chance that it's still there. So you can never really falsify a statement about something existing. That's just a natural fact of formal logic, basically. So for example, let's say we have the statement hydrogen exists. Okay, is that a scientific statement or is it not? Okay, we can never really prove that hydrogen. There's no way we could prove that hydrogen didn't exist. Even if we had no reason for thinking that it exists, that is still not proof. That is not falsification of this fact. That's the thing. Now, for hydrogen, it might feel obvious. Okay, well, maybe that's an exception. But what if you say something like God exists? Okay, God exists and hydrogen exists are statements that are logically equivalent. But we sort of want to say that hydrogen exists is a scientific statement, and Popper maybe wants to say it's a falsifiable statement, so it's counted as science. Whereas God exists, formally the same thing, but we also feel like maybe that's not a question of science. Maybe that's something a little different. But that still is one of the problems with Popper. I mean, it's any statement about the existence of something that we might not have evidence for. Again, God is a very big example, but even things that scientists obviously believe in, like, the earth or hydrogen, technically in Popper's metric, those aren't really scientific statements. So it's a weird thing to sort of go on about. Either way, as the field of philosophy of science advances, you really get to the heavy stuff, or not the heavy stuff, the important stuff, the really, transgressive stuff, when you get to Thomas Kuhn. Kuhn, of course, wrote this book called The Structure of Scientific Revolutions, okay? And it's relatively famous. Again, I think it's nothing compared to Feyerabend, but it's probably a good bit more famous than him. Now, what this book is about is the idea that if you actually look at the history of science, it's not about verification, it's not about falsification. What really happens is that science advances by, there are people who work within a paradigm. Let's say the paradigm of geocentrism, okay? And they can explain a lot of the universe in terms of geocentrism. Like Ptolemy made a very effective model of how the universe works, how the planets move around in the sky, and it had a lot of empirical validity. And there was no reason really to abandon it. It worked fine. And that paradigm existed and was coherent with itself. And you could even use it to discover more about the universe, and it worked. And by all the positivist metrics of incremental science, you could discover more about the universe in it. But what happened, and how Kuhn paints the history of science is really, science doesn't change by just learning new facts. That's sort of the thing that positivists want to think it is. It's just adding new information, and then if we change our interpretation, it just magically comes directly from the information. But that's not really how it is. Kuhn says, really what happens is someone comes up with a wild new idea, which radically reinterprets everything else. In the case of geocentrism, there's the Copernican model of heliocentrism, which Galileo ran with. And of course, at the beginning, it's not a very good model whatsoever. I mean, it doesn't account for anything. And we'll talk about some of the things that heliocentrism can't do, or at least couldn't do at this time. But over time, you sort of see, okay, well, maybe this one might be better. We flesh out the theory there. We can validate more of the stuff. It seems more plausible. And it actually, maybe even it accounts for some things that geocentrism doesn't. Importantly, different scientific paradigms have totally different methodologies sometimes. They have totally different base assumptions, and you can't really translate from one to the other. They're just a different world. What a planet is in our view of the universe is something like the Earth, which is circling around the sun. Whereas a planet in the Ptolemaic universe, a planet is, literally comes from the Greek word for wanderer. It is a star in the sky that, seems to go one way and then briefly loops backward and then loops again and goes back the way it was going. So planets, they're an object in the sky that wanders across. It has nothing to do, the basic assumptions are very different. So Kuhn brings this idea to bear that really it's not just about facts. I mean, facts are a minor detail sometimes of science. Really, it's really total worldviews that are changed and that I guess force in new ways of looking at data, reinterpreting data. And it's not always that it's something constant. I think we have this idea, we'll get to this when we actually get to Feyerabend, which I keep talking up, but we have this idea that science is constantly adding to knowledge. In reality, we're just adopting models that may or may not have the same validity in terms of, they might not be able to account for everything that the Ptolemaic system did. But that's often how it is. Now, Popper, actually in his introduction to his book, gives a good rendition of this fact. He says, I'm going to be quoting, this is actually only from page 2, but he says, in recent years, however, a few historians of science have been finding it more and more difficult to fulfill the functions that the concept of development by accumulation assigns to them. As chroniclers of an incremental process, they discover that additional research makes it harder, not easier, to answer questions like, when was oxygen discovered? Who first conceived of energy conservation? Interestingly, a few of them suspect that these are simply the wrong sorts of questions to ask. Perhaps science does not develop by the accumulation of individual discoveries and inventions. Simultaneously, these same historians confront growing difficulties in distinguishing the scientific, that's in quotes, component of past observations and belief from what their predecessors had readily labeled error and superstition. The more carefully they study, say, Aristotelian dynamics, phlogistic chemistry, or caloric thermodynamics, the more certain they feel that those once current views of nature as a whole are neither less scientific nor more the product of human idiosyncrasy than those current today. If these out-of-date beliefs are to be called myths, then myths can be produced by the same sorts of methods and held for the same sort of reasons that now lead to scientific knowledge. If, on the other hand, they are to be called science, then science has included bodies of belief quite incompatible with the ones we hold today. So Kuhn's point is that really, if you look at the history of science, again, especially starting in the 20th century, there's this tendency to say, well, this is science and this is not. For example, we look at alchemy. We say that, alchemy, it's maybe a pseudoscience, it's a proto-science, they did all these weird things. But if you actually look at alchemy, the actual history of alchemy and the mindset behind it, first off, they actually did good experimentation. They give us lots of notes, and they actually discovered a lot of things about early chemistry just by doing alchemy. Now, the foundations behind alchemy might be different from what we now think, but it was still, it was a theoretical language that made a lot of sense and discovered a lot about the universe. Same thing even with astrology. Now, of course, astrology nowadays, we don't even know anything about it. We just think of it as horoscopes, but that's not actually what historical astrology was about. But either way, there's this tendency to say, okay, well, and again, this is a novel tendency. This did not exist in previous eras. When you looked at alchemy or astrology, and of course, a lot of old scientists, of course, Isaac Newton himself was an astrologist and an alchemist and a hermeticist and stuff like this. But when they looked at these issues, they didn't say, oh, well, that's something different. That's pseudoscience. I'm not going to pay attention to that. Okay, so Kuhn starts to open, okay, well, maybe this demarcation problem, it's not so much of a thing. Maybe it's not a big issue. We might be believing it for our own self-serving purposes. So we can say, well, we are the consensus, and it's not just that we are right, it's that the other people are doing something that isn't even science. It's not even I mean, and think about it. Okay, where does the word science come from? Who knows, right? It's actually just a Latin word that means knowledge, okay? Now, in Latin, it literally just means knowledge. You can have knowledge about anything else. You can have knowledge of divination or something like that. But in English, and of course other modern European languages, since we have this extra term that we've borrowed, we have historically repurposed it for this different concept of knowledge, this magically more official concept of knowledge that is supposed to be held to a higher standard. Well, is it actually held to a higher standard? I think it's about time for us to get to Feyerabend. Now, Feyerabend actually comes to the scene. He writes this book called Against Method. Now, originally it was supposed to be a joint book with a man named Irme Lakatos. I'll talk a little bit about Lakatos. But Lakatos and Feyerabend had similar views. They both definitely were in this Kuhnian environment where the idea was emerging that, okay, well, maybe the demarcation problem isn't so simple. In fact, maybe it's not even a problem. Maybe the whole issue isn't so much of an issue. But anyway, originally, the book, Feyerabend's book, Against Method, was supposed to be a book for and against method. It was going to be him and Lakatos debating these issues. Lakatos was a little more, I guess, a little more conventional than Feyerabend. I'll talk about how their differences were. But Irme Lakatos actually died, and then Feyerabend ended up just having this book by himself. So what is it about? So he takes as an illustration of his point the example of Galileo. Now, as I said, Feyerabend is a proponent of the idea of epistemological anarchism. What is that view? It's the idea, actually maybe I should read it from the very beginning of the book. Why not? I didn't even put it in my notes, but I should. But he does give a little view of it. He's a proponent of epistemological anarchism. And that's nearly what it sounds like. The following essay is written, this is him at the very beginning, the following essay is written in the convention that anarchism, while perhaps not the most attractive political philosophy, is certainly excellent medicine for epistemology and for the philosophy of science. The reason is not difficult to find. That is, what he's talking about is really we need to throw away the demarcation problem, okay? We need to totally get rid of it. And a good scientist, again, in the vein of Newton or anyone else before him, the thing is Newton is sometimes talked about as being an occultist. He was actually everyone back then did alchemy and considered it science. But in the vein of earlier scientists, we can't necessarily say that there is some magical category, that the category distinction between so-called science and everything else. We have to be able to look at other domains for our views. Now, he uses, as I started saying before I interrupted myself, Galileo as a perfect example of this, because Galileo, here's the court history view of Galileo. And again, this is basically false, but this is what you're told if you watch Neil deGrasse Tyson's Cosmos, okay? Galileo, he lived in a time of religious oppression, and the Catholic Church just told everyone what to believe, and, they believed that the Earth was at the center of the universe and probably flat, but they believed the Earth was the center of the universe, and Galileo, he did... he learned science and, owned them epic style with facts and logic and proved that the Earth is, definitely moving around the sun. And he had lots of good reasons and they all knew it, but they were just so irrationally devoted to their religious convictions that they persecuted him. And it was really sad. He was a martyr for science. That is the pop culture idea of Galileo. Now the thing is, and of course this is actually not just true of Galileo, but this is the view of, Giordano Bruno. Maybe I should talk about him in a podcast. He actually was a hermeticist. Now, if you watch Neil deGrasse Tyson's Cosmos, he also is viewed as like a martyr for science. He was really just an occultist, who had very interesting ideas, but we'll talk about that, in another episode. Either way, Galileo, what actually happened with Galileo? What was the difference? Now, here's the argument that Feyerabend makes. First off, Galileo was basically wrong. Or, not really wrong, but wrong in a scientific sense. That is, if we held the standards of modern science to Galileo, he actually fails tremendously. Not by a little bit, but tremendously. Now, Galileo is a person. Now, one of the reasons Galileo was persecuted as a scientist was not because he was just like some guy saying claims about the universe. Well, first off, the church, although they had Aristotelians in the church, you have to remember that the view of the universe that was common and taught at that time, especially in the schools of the Catholic Church, it was not like a religious viewpoint. It was ultimately an Aristotelian viewpoint. But Galileo was not the first person, obviously, who endorsed geocentrism. There was Copernicus, and he didn't really have the same level of persecution or something like that. Galileo was actually a big troll, and everyone sort of knew it. Like when he wrote his dialogues, of course, he, like Plato, wrote dialogues. Like he didn't explain his viewpoint just in prose. He would pose theoretical questions as if in a conversation between, 2 or 3 different people. So he'd have the smart person and the dumb person and maybe the person in between, and they'd all sort of debate. And that was his writing style, the dialogue writing style. Now, in his dialogues, actually, there was a guy, I want to say his name was Simplicio, which is basically Italian for simpleton, or basically brainlet. And he was the guy who said all the things that the church or, the authorities of the time would say. And Galileo ended up being sort of kind of troll. He liked messing with people. He liked prodding them and sort of undermining authority. So he wasn't very respectful of the scientific authorities at the time. But even aside from that, let's talk about the scientific metrics on which Galileo fails. And Feyerabend goes through chapters of them. I'll give just 2 that I think illustrate the point pretty well. Now, first off, one of the biggest faults in Galileo's view, and of course we have to put ourselves back in that time, given what people know, because we can't just say, oh, well, we know that Galileo was right, therefore anything he said was right. In reality, the reasons he had for things were a little unclear, okay? But one of the biggest examples is this, okay? And this is something that Galileo's debate adversaries would bring up quite a good bit. Let's say you're on top of a building and you drop a book off of that building. All right, where is the book going to land? Now, everyone knows the book is going to land beneath you, like right below you. If you look down, you're going to see a book, unless it, the wind is just so strong it blows it a little bit. But if Galileo's theory is true, and the Earth is actually turning around, it's actually revolving, the book shouldn't really land right below you. It should actually land maybe a couple feet to one side. If you're on a really big building especially, it might land, a good bit away. Maybe if you drop it off a mountain, it'll be a couple miles away because the Earth is moving during that period. Now, of course, nowadays, with our contemporary views of science, we'll say, oh, no, there's, all the stuff with momentum and inertia and stuff like that, and that explains it. But Galileo at the time had absolutely no way of explaining where this came from. He basically just said that, yeah, okay, I know that I fail here empirically, and I know literally everything that drops is basically a falsification of my theory, but let's just run with it. Let's see what happens. That was basically Galileo's proposal, and that's what Feyerabend notes. Now, this, of course, is basically an unrational, it's a very anti-positivist, it's an anti-falsificationist thing to do, but Feyerabend says Galileo was doing it. It was irrational in some sense, but science, this is good that he did that. That is how you do science. When Galileo ran into an exception to his theory, he just ignored it. Or another exception that's probably a bit more obvious, we don't even think about this kind of stuff nowadays, but at the time, let's think about the difference between the Ptolemaic Aristotelian world, where the Earth is in the center and the stars and the planets circle around it in some way, and the heliocentric world, model of the solar system. One thing about Ptolemy's, geocentric model is that, the planets, again, they're wanderers in Greek, and they just, go across the sky and they decide, oh, you know what, I'm going to go back for a little bit for this period, and then I'm going to loop back and continue the way I was going. Okay, that's how planets work. And one thing about them is they're basically always the same size if you look at them. Okay, Galileo, however, his theory states the idea that the Earth and Venus are both planets, states that at different times of the year, Earth and Venus might be really, really close, or they might be something like 60 times the distance away. And one thing that Galileo's adversaries noted very quickly is, well, duh, obviously this the star of Venus does not get 60 times further away during the course of the year. That doesn't happen. Maybe it even changes size, but it doesn't change size by by an interval of 60. That does not happen at all. It doesn't happen with any of the planets. And again, Galileo had absolutely no way of refuting this. And even nowadays, that's something you have to have very particular modern views of optics to make sense of that kind of stuff. Anyone who looks in the sky can obviously see that the planets, they don't change from day in, day out. They're all pretty much, they're moving in a weird direction, but Ptolemy's universe perfectly explains that. It perfectly models it in good standard positivistic science. Whereas Galileo seems to propose that the planets should be drastically different sizes. Now, even more than this, there are these kind of empirical points, but even more than that, Galileo was also doing a totally novel kind of instrumental science. And what I mean by, and this is something that Feyerabend notes as well, Galileo, as many people know, was using a telescope, and that was a novel thing. For example, he was looking at Jupiter, and he saw what he thought were moons circling around Jupiter, and that was sort of the metaphor that got his brain thinking, maybe everything else is circling the sun. But one thing about that is, if we look at that from the viewpoint of modern science, I mean, try and think of it today. Let's say there's a fringe physicist nowadays who invented this machine. He says it's some kind of quantum device that can tell him things about the universe. And only he has one. Maybe some other people are trying to build one. But basically, he's the only one who's doing research on this magical quantum device. And he says all of modern physics is totally wrong. He's disproven it. Okay? That's just, why would we believe someone like that? That just seems like a weird thing to do. Well, in reality, that's exactly what Galileo was doing. He was using this device that no one had any reason to think that it was accurately representing the heavens. Even if Galileo found evidence that supported his side, which, as I said, in the case of the size of Venus, he frankly didn't always find. But even if he did find evidence to support his view, how could anyone really validate that? This is a perfect, Feyerabend is genius to use this example because Galileo omits data. He makes ad hoc hypotheses to explain it away. He doesn't even care. And he even uses instruments that are totally, have no recourse in the quote-unquote peer review system. Oof, the peer review system. I think not related listeners will know that the peer review system is extremely fake, but maybe that's another episode. So either way, this Feyerabend uses this example, and I think it's so perfect because on one side, it's that thing where everyone believes in it. Everyone is like, oh, this is a perfect example of science advancing. But the side of facts and logic was the side of the Catholic Church. They had no reason. Galileo presented no novel evidence to really show that the previous theory was wrong. Even if his statements about the moons of Jupiter, or at least apparent moons of Jupiter, were true, that doesn't necessarily disprove the Ptolemaic model. And additionally, Galileo had all of these problems in his theory. So now what Feyerabend is saying is he's not saying, okay, well, you sphere cucks are wrong, and actually the Earth is the center of the universe or something like that. What Feyerabend is saying is this key event in the history of science is a good example of how crazy ideas that are by our definition, pseudoscience. They're unfalsifiable. In fact, the people who promote them are ignoring data. They're just making stuff up as they go. This is a perfect example of the advancement of science is actually a good example of low scientific standards. That's one of the things he notes. And even people at the time noted this. He quotes actually Descartes, if you actually, on Feyerabend's book, this is on page 69, he quotes Descartes as saying, "It seems to me that Galileo suffers greatly from continual digression and that he doesn't stop to explain all that is relevant at each point, which shows that he has not examined them in order and that he merely sought reasons for particular effects without having considered first causes, and thus that he has built without foundation." That is, Descartes, who obviously is a famous philosopher, scientist, whatever at the time, is saying, well, Galileo, he obviously just wants this to be true. He's looking for rationalizations for why this is true, and he's ignoring consensus. He's totally ignoring the much more solvent theory that goes on in here. So anyway, I'm going to take a little break. I feel like I've been going a little long, so I'm going to take a break, read some donations and emails. I think I got a couple. I'm recording this like literally the day after I put up my announcement that I'm restarting this. So I don't know how many I have. I'll have to check. But after that, I will talk a little bit more. We actually have a lot more to talk about. So I'll be back in just 1 second for you. Galileo violates important rules of scientific method, which were invented by Aristotle, improved by Goethe, among others, canonized by the logical positivists, such as Carnap and Popper. Galileo succeeds because he did not follow these rules. His contemporaries, with very few exceptions, overlooked fundamental difficulties that existed at the time, and modern science developed quickly and in the, quote, right, unquote, direction, from the point of view of today's science lovers, because of this negligence. Ignorance is bliss. Conversely, a more determined application of the canons of the scientific method, a more determined search for relevant facts, a more critical attitude, far from accelerating this development, would have brought it to a standstill. That's Feyerabend on page 112. All right, I'm going to read some donations. I did get some relevant to not related, at least. And then I will actually cover some more stuff, not just a couple more quotes from the book, but how it's relevant to science right now. Not just science, I should say that. This is actually, one theme of a lot of my podcast episodes is they have very sublimated ramifications in the real world. I don't know if these are, I don't know, maybe you're not big-brained enough to see them, I don't know, or maybe I'm just imagining them, but of course, we all know, if you listen to this podcast, you are big-brained enough. Anyway, I'll read some donations. $5 from Felix, no comment on that one. $50 from Dion. He gave this donation via Zelle. By the way, donate at lukesmith.xyz/donate. There are a million different ways to donate. I have crypto, got Zelle, PayPal, all that kind of stuff. Zelle, for those who don't know, it's like a sort of interbank processing thing. You probably actually already have it if you're an American. I will say, so I did get this $50 from Dion. I did not see a comment on it. If you do send a Zelle donation, I'm not sure that they always show comments. So you can feel free to email me at my email address, Luke at lukesmith.xyz, if you have an additional comment for that. And that includes Dion if you did have something to say. Either way, thank you for the $50. $5 from Lionel. Greetings from France. Thanks for all the content you produce. You share your knowledge and your points of view as very few people dare. That makes me keep faith in humanity in this digital age we're living in. Glad that Not Related, the podcast, is coming back. Thank you, Lionel. $12.07 from Douglas. Hello, based NPR. Lol. UK listener. Just took up gardening this year, also reading John Seymour's self-sufficiency book, Individualism in the Western Liberal Tradition, and Rip Ford's Texas. I don't know what that is. Appreciate you bringing back Not Related, as you're a busy guy. Hopefully you saved a few guys from burned down apartments. Oh yes, if you're referring to the fact that most of the cities in this country are burning down. Thankfully, I live nowhere near any of that. We all live out here where there are far more guns than people, and everyone keeps their doors unlocked and their keys in their car. Although I'm thinking maybe I should, start being a little more. Oh, okay, I lock my door. I lock my doors, but just because I think I'm a e-celeb or something. So anyway, thank you for the donation. So here's a non-donation, but I want to read it because why not in this case? This is from Anonymous. He calls himself Mr. Red Blue. I've been regularly watching your YouTube videos for a couple months now. I've also listened to a few episodes of your podcast and also read your blog posts. The blog posts best, so easy to get and read thanks to Newsboat. I really appreciate how you do things very efficiently with your computer. I can't comment on YouTube because I don't have an account, so I thought it'd be a great idea to appreciate your work via email. According to your last YouTube episode, I found that your second season of your podcast, Not Related, is coming soon. That's really exciting. I have one question. Would it be possible for you to release the transcript? This is a good question, by the way. Would it be possible for you to release the transcript of your podcasts as a blog so that we can read what you said in your podcast without actually listening to it? Because reading is much faster than listening to a podcast. Also, he says, please consider distributing your podcasts in OGG Vorbis or any such free formats instead of MP3. Well, I actually am distributing this season in, I want to say OGG, either OGG or Opus. I think it's OGG. And yes, although I think technically MP3 is free nowadays, I did use MP3 for the last... There are some problems with OGG. Apple users have trouble with them, but whatever. Either way, on making transcripts of the podcast, that's an interesting idea, an idea that I've actually thought about before. That's a lot of trouble to do, I will say that. I mean, if I'm talking for an hour, that is a very long... I mean, unless you just want me to rewrite it as an essay, but that's still a lot of work. So you might say that it's easier to read than listen, but it's also easier to talk than to write, definitely for me. Although, I might look into software. If anyone knows any software that's very good at voice recognition and transcription, I might take that into account. I've actually thought about publishing the podcast episodes in a little book that you can get. But anyway... and $10 from, gotta look at it, Kolmatov. I'm not quite sure. I forget how to read Cyrillic, but whatever. The first letter looks like an X. Do they pronounce that as a K or a H? I don't even know. But thank you for your $10. I don't think there's any comment on that. All right, so I read that quote by Galileo when I started, right before I read donations, and I think, or not from Galileo, on Galileo in Feyerabend. And again, the point is, Galileo made an impact on the scientific field because he ignored facts and logic, because he was willing to make ad hoc hypotheses and willing to go a little further. Now, I did say that there was another guy at this period, in addition to Feyerabend, his friend Irme Lakatos, and they almost wrote a book together called For and Against Method. Now, there is a book out there called For and Against Method. It's by a guy, Matteo Materlini. It was sort of he actually went and compiled the writings of Lakatos and Feyerabend, the things that they already had written, and published them. So you can actually get that if you want their back and forth. But Lakatos, his views were a little more conventional than Feyerabend. Now, Feyerabend basically believes that so-called pseudoscience doesn't exist. It's basically the same as science. Lakatos really says, okay, well, yeah, that's sort of true, but within a particular scientific paradigm, we can at least say, oh, this one is progressive, it's making new discoveries or something like that. So if you want to check out the dispute between Lakatos and Feyerabend, check out the Materlini book. Again, I have it listed in the comments or what have you. So I will say, one, I guess, argument to absurdity that you might want to make at Feyerabend at this point. He's saying that pseudoscience and science are the same thing. Does he really want to say that? What kind of crazy things? I don't know. What you think? Like the Bible is science? You think old mythology is science? And Feyerabend's response is yes, it is science, or at least we have to. If we are scientists, we have to be available to look at any kind of idea. He actually quotes from a professor's review of his, this is on page 49 of his book. He's quoting from this woman who reviewed him an earlier paper. I'll just go ahead and read it. If anything goes, writes Dr. Hesse in her review of an earlier book of mine, then the question arises, why do we not go back and exploit the objective criticism of modern science available in our Aristotelianism, or indeed in voodoo? And she insinuates that a criticism of this kind would be altogether laughable. Her insinuation, unfortunately, assumes a great deal of ignorance in her readers. Progress was often achieved by a criticism from the past, of precisely the kind that is now dismissed by her. After Aristotle and Ptolemy, the idea that the earth moves, that strange, ancient, and entirely ridiculous Pythagorean view, was thrown on the rubbish heap of history only to be revived by Copernicus and to be forged by him into a weapon for the defeat of its defeaters. The Hermetic writings also played an important part in this revival, which is still not sufficiently understood, and they were studied with great care by Newton himself. So Feyerabend's point is, in the past, all of these things we don't consider science. I mean, even if you don't, if you look at Hermeticism or you look at, young Earth creationism, even if you look at those views as sort of, you can't specifically defend them in their specific claims, a lot of times we look at traditional ideas for inspiration for things that might drive us on. Now, one book that I've actually talked about in live streams, I see it on my bookshelf now, so I want to talk about it, is a book by this, so there's this boomer, boomer named Michael Cremo. You ever heard of this guy? He's an interesting guy. He's one of these, I guess he converted to Hinduism. I don't know. He might actually be Indian or something like that. He looks white to me, but so Michael Cremo, and that's also not a very Indian name. He has some kind of Indian name, but he is basically a Vedic creationist. And he believes that humankind, one of the ideas in the Vedas is that humankind has actually existed for millions and millions of years before, earlier than what scientists usually believe. Now, of course, you might totally disagree with Michael Cremo. You might think that the reasons he has for believing that are dumb, but he has written some pretty interesting stuff. I'm looking at his book, Forbidden Archaeology, which is not actually really even supposed to be a scientific interpretation of anything. He really just lists aberrant scientific, archaeological sites that date back way before they're supposed to date. Humans are supposed to be 100,000 years old, or, well, actually even less than that. You should actually watch my podcast on human evolution, but humans are supposed to be so ever long old, but there's always evidence coming out that's sort of ignored of them being a little older than that, or actually sometimes much older than that. And Cremo's point is that if you're someone with a different perspective like him, and this is something Feyerabend would emphasize, if you're someone with a different perspective who has a religiously motivated idea, you are much more likely to say, you know what, maybe all of this data, we can't just write it off. Maybe we should actually try to integrate it into scientific knowledge. Maybe that is a legitimate thing to do. And as I talked about in my podcast on human evolution, it so happens that one thing that is actually happening is that as time and time goes on, the idea is that humans have actually been, it becomes more clear that humans have actually been around a lot longer, sometimes an order of magnitude longer than what scientists originally expected. Okay, that's a good example of, you might take a religious belief and think it's ridiculous, but sometimes when you play with ideas, even ideas that you might disagree with, they give you a perspective that you wouldn't have otherwise. Whereas if you are simply inculcated in scientific incrementalism, where the idea is, well, science, we've basically figured it all out, and we just have to we gotta, tweak the details here or there. That is where, that's boring. It's boring and it's not effective. And we would still believe in the Ptolemaic universe. So I know we're about at an hour now, but I want to leave you with at least one more anecdote. And this one might be pretty important and relevant for people out there. There's a guy out here, there's a physics professor named Gerard Toft, or I guess it's Gerald Toft. I mean, it's a Dutch name or something like that. Now, he's a famous physicist. I think he actually won a Nobel Prize or something like that. But he's one of these hall monitors, so to speak, a kind of guy that Feyerabend would really hate, because he's this guy who's always looking about, we gotta fight fringe science, and we have to fight pseudoscience and stuff like that. Now, Toft, and this is, it's a Dutch name, it's spelt like apostrophe T and then space Hooft. I don't know why I'm telling you this, it's in the comments and description, whatever, look at it yourself. Here's a little essay I found that I really liked, and it's called The Importance of Recognizing Fringe Science. Because although this guy thinks of himself as a arbiter of consensus, I think he admits some things that Feyerabend would actually very much agree with. So he actually mentions what he thinks of as being the characteristics, he gives 4 of them, characteristics of fringe science. And I want us to think about these, because again, this is from the mouth of a guy who actually believes that pseudoscience and fringe science is an issue. Let's think about these. The first one he says is, I'm reading from this essay he wrote. It's called The Importance of Recognizing Fringe Science. I'll have a link to it. The first one that he mentions is polemics. I'm quoting, "Fringe papers often claim that a whole gang of practitioners of mainstream science are defending, quote, wrong, unquote, notions, and that they conspire just to ensure university positions and their salaries." Well, first off, I mean, if consensus scientists are wrong on something, and I think we saw in Popper that it's actually very easy to falsify a specific idea, and really we saw in Kuhn it's not so much a battle between factual information versus factual information, but it's really a difference between paradigms and how you interpret those facts, right? So, yeah, of course, there are a lot of people who look at mainstream physicists and say, yeah, they're wrong. They have wrong notions. And I don't think it's too crazy to say, yeah, people who have tenured positions want to be tenured. And, you know, one thing, okay, let me make a comment. I'm sorry, I got to single out all you Redditor sort of Neil deGrasse Tyson thinking people out there. I know there's this idea that science, institutional science, it's really great because I hate it whenever I hear someone, because, anyway, let me just say what I hate. There are people who will say this stuff like this. Well, science is great because, you know, it actually encourages you to question assumptions, man. You actually, you know, if you get famous if you question assumptions and you go against the grain and stuff like that. And that is something that the only people who could ever say that are people who just have no exposure to how academia works. That is just not true. And it's not even like there's a malicious conspiracy of consensus academics. It's really, that's just how life is. I mean, let me give you a minor example. You know, in graduate school, one of the reasons I went to the University of Arizona for graduate school is when I went there for our campus, you know, I was accepted there and they invited me to campus to view it. And, you know, there was this guy, I've actually talked about him in another episode. His name is Dave Medeiros. He's out there. He had some really just out-of-the-box, crazy, interesting ideas. He had this idea that language was just a big stack sorting algorithm and stuff like this, and you can account for all these interesting things in language by assuming that, and you could just totally remodel everything about, you know, how we model language. And I was really attracted to that idea. I mean, not just that idea, not to say that I'm one of his followers or something like that, but it just proved that, oh wow, at this school you can definitely do cool stuff. Well, I went to the university there. I did decide to go, probably a regret of mine. Definitely a regret of mine, but anywhere else probably would have been just as bad. And one thing is that when Dave actually went out to try and get jobs, it was a difficulty. And it's not because people were conspiring against him because he had these views that went against mainstream generative syntax. I mean, maybe they were, but even if they weren't, you know, if you have someone applying for jobs or applying for a position who says, you know what, oh, I know about the mainstream stuff, but I actually believe in that it's totally wrong and we do this. Can you actually, I mean, is it safe to rely on someone like that to teach classes? I mean, I'm trying to put myself in the shoes of a consensus physicist or a consensus linguist in this case, or just any consensus scientist. There absolutely are institutional boundaries for people with novel ideas into getting into these positions. And yes, it persists even while, you know, when they have to constantly publish stuff in particular journals. That often limits you to very mainstream journals. Even if you're a tenured professor, you have to do stuff like that. So anyway, this is a big digression from Toft's little essay here. Again, he says polemics. This is what he calls polemics. So people say that, mainstream is wrong, and or what he calls fringe people say that the mainstream is wrong, and they conspire against us, which is trivially true. His second point is that fringe science, allegedly, he says, their arguments arguments are employed that are quite unconventional as compared to the standard theories, while they nevertheless may sound professional. Well, yeah, that's true. Is that your definition of fringe science? In keeping with Kuhn, yeah, different scientific frameworks are going to have totally different approaches. If you look at the geocentric model and compare it with the heliocentric model, I mean, the heliocentric model proposed a totally new way of looking at data. They even had their own instrument, the telescope, which was basically pseudoscience, unverifiable stuff. So yeah, of course, different frameworks have totally different ways. Now in linguistics, actually, this is the case as well. I have a lot of bad things to say about linguistics, but one good thing about it is that there are actually different approaches that different schools have. It's not necessarily like economics or physics, where basically every school has more or less the same thing going on. The nice thing about linguistics is there are some people who do the Chomskyan stuff, which I think is dumb, but you know, whatever. I guess I went to a school that did that, but whatever. There are some people who do the Chomskyan stuff. There are some people who do all statistics and want to do like sort of neural net stuff. There are people who, if you go to like BYU, the Mormons over there, they're very interested in, I almost want to say they're more structuralist if you use that term liberally, but they're more interested in language documentation, traditional language analysis, because a lot of them want to, convert people in tribes or something like that. Anyway, in linguistics at least, there are different theoretical frameworks, and guess what? Each one of them mutually excommunicates the other. And that's frankly a good thing, because at least people who study linguistics nowadays have the ability to go somewhere else and hear a different viewpoint. They can go to Europe and hear the structuralists there. I'm actually spending more time on this little essay than I thought I would. But anyway, his third point, so I'm quoting again, the major parts of these arguments explain why the standard theories are totally untenable and how they should be replaced. Quantitative analysis as to how one should replace the standard theories is rarely provided. They think that it suffices to state that the standard theories are wrong, so the things they replace them with need no further justifications. Now, we haven't talked about this one as much, but this is a common... This is very anti-Popperian for him to even say. Now, Popper's view, of course, is that if it's falsified, get rid of it. Now, that's a very stringent thing. I don't believe in that, but that is often held as the standard for science. Regardless, if you in a lot of cases, now, this guy, Toft, he's actually usually talking about particular physicists out there, or I should say fringe physicists in his view. I think a lot of I know he's written a couple stuff against a guy called Stephen Crothers. You should look him up on YouTube. He's this guy who I think was kicked out of a PhD program in physics or something like that. But he basically is against relativity and things like that and says, they're formally incoherent. You can look up the arguments yourself, whatever. But, what's wrong with a guy saying this particular theory is wrong, this way of approaching it is wrong, it has fundamental flaws that are causing problems? Does he need some alternate theory? One of the things that both Feyerabend and Kuhn touch on is that when you replace an old theory, it's not always the case that you're going to explain literally everything about it. You can't hold novel approaches to that standard. That's just not going to happen. And a lot of times novel approaches are really just stripping away theoretical junk. Okay. Now his last point is the authors have not been able to get their work published in scientific journals that would have been chosen by professionals. Such journals are peer-reviewed, and no reviewer would have approved the work. This is because professional reviewers have no difficulty spotting the fatal shortcomings. Now, this, of course, is sort of begging the question. I mean, this is the same thing as saying, well, yeah, we exclude fringe people, and if we're peer reviewing their stuff, of course they're going to be rejected. Obviously, they're going to be rejected. Why would they not be rejected? If you're coming with a totally novel theoretical framework and you're trying to send your stuff into some journal that is more mainstream, you're not going to get accepted. Again, the idea that there's this drive to find novel. I mean, scientific incrementalism wants to find new data, but new data within a very limited set, within a limited approach. People don't really, you can't just publish in one of these journals a totally novel approach to something. And weirdly enough, the third point of his sort of contradicts the fourth, because he's saying, well, we can readily see the errors in their problems, but he also says, or the errors in their theoretical framework, but he also says it's a bad thing that they can immediately identify the problems in ours. Isn't that a little contradictory? And the question I would leave someone who thinks like this guy is the following. Let's say, quote-unquote, fringe scientists, fringe physicists. Let's say the example of Stephen Crothers. Again, you should look him up. He's sort of interesting. I don't necessarily vouch for everything he says. I don't know the specifics. But let's say Stephen Crothers and his friends take over physics. Well, is he pseudoscience? Is he fringe science now? Because now he controls the journal. And you don't get to publish. He controls who gets hired. And yes, he conspires against you. He thinks your ideas are wrong. You think his ideas are wrong. That doesn't mean that you are doing polemics or something like that. And yeah, your view, if you were to trying to get into his department, you couldn't do it because you have unconventional methods. So one of the reasons I wanted to note this little thing, and it took a little more time than I thought, but I guess we touched on good things, but one of the reasons I wanted to touch on this little essay on fringe science is just because this guy basically admits that really what fringe science is science that is not institutionalized. There's not really a, factual, theoretical difference between science and non-science. He's sort of tacitly saying that because all of his requirements for what constitutes science are just, you control the institution. Okay? And Feyerabend sort of is saying the same thing. He's saying, well, in reality, what is science? It's just the thing that we do. And, pseudoscience is just a word that we make up to lambaste the people we don't agree with. And it's Feyerabend's view that we need to be not more accepting, not open your brains or open your minds and let your brain fall out, but you need to be able to look at alternate views that seem to you insane, and look at their intuitions. When it comes down to it, everyone believes something for a reason. Look into those reasons, even if they sound crazy. All right. This has been long enough. I feel like I've gone way over. So I'm going to stop the recording. I'm looking at my notes for this episode. There's a lot more I wanted to touch on. I thought I was going to have not enough content. Ended up I have too much content to consume. So I guess you'll have to consume the next episode of Not Related. Again, go to notrelated.xyz, subscribe to the RSS feed. Go to, if you have a question or comment, send it at lukesmith.xyz/donation, and I will read donations at the middle break of the next episode. All right, that's about it. I'm getting sweaty because I turned off my AC so I could record better. I'm going to turn it on. See you guys next time.